Good evening. Good evening to everyone. Okay, so today we will discuss a replacement process. I think my voice is audible. I think you can also see the slides. If there is any problem, you can tell. Okay. So in the last class, I told that these results, that is, P implies Q and P implies R is equivalent to P implies Q and R. So I'll take the left hand side. Actually, this is a is like identity, but I gave the proof here. P implies Q and P implies R is equivalent to P implies Q is what? Negation P or Q, and P implies R is negation P or R. So here you can see here this is here you have and here you can see it is R. It is negation uh, PR. So negation PR. So here I am using distributive law. To use distributive law, you can okay. So if you use distributive law, you can take negation P R. So Q and R. So from here to here, I am using distributive law. So and then from here to here, I am applying P implies Q. So P implies Q is same as what? Negation P or Q. So negation P or Q is same as what? P implies Q. Okay, this is the first result. Second result, P implies R and Q implies R is equivalent to P or Q implies R. So I will take the left hand side. P implies R is equivalent to negation P or R, and then and Q implies R is negation Q or R. Okay, again here you can see and okay, and here R R. Okay, R R. So again I'm going to use a distributive law. So I'm going to take R R separately. So remaining what? Negation P and negation Q. Okay, from here to here I'm using De Morgan's law. Negation of P or Q or R. Now this is of the form negation of P or R. So you can write what? P implies Q. P implies Q is what? P or Q implies R. So we got the final answer. For third one, P implies Q or P implies R is equal to P implies Q or R. I'll take the left hand side. P implies Q is what? Negation P or Q, or P implies R is negation P or R. So you can see everywhere you have what? R, R, R. So just you can apply commutative and associative law, and also you can apply P or P is P. Okay, here I'm using P or P, that is negation P or negation P. Okay, after applying associative and commutative law, you will get negation P or negation P. So that is equal to negation P. So R remaining what? Q R R. Okay. So now again this is our form negation P or Q. So you can write what? P implies Q. So P implies, instead of Q I have what? Q or R. Fourth one, P implies R or Q implies R is equivalent to P and Q implies R. So I'll take the left hand side. P implies R is what? Negation P or R, or Q implies R is negation Q or R. So here everywhere you have R R R. Apply associative and commutative law repeatedly. You will get a negation P or negation Q, and R R R is again R. Similarly, this one. So now from here to here, I am going to use De Morgan's law. So negation of what? P and if I take negation common, negation of P and Q or R. Okay. So, sorry. I think I am explaining the third result, yes, fourth result. If I take negation commonly, you'll get what? Negation of P and Q or R. So this is equivalent to, this is of the form negation P or R is equal to what? P implies Q. P implies Q is what? Here P is what? P and Q implies R. So these four results are uh, equivalences involving conditional statements. So next, equivalences involving biconditional. So last class itself I told that P biconditional Q is equivalent to P implies Q and Q implies P. Second one, P biconditional Q is equivalent to negation P uh, biconditional negation Q. Third one, P biconditional Q is equivalent to P and Q or negation P and negation Q. So this result is important one. Should remember this result, okay, to solve the problem. But I am giving a proof here. P biconditional Q is equivalent to, using the first one, P implies Q and Q implies P. P implies Q is what? Negation P or Q, and Q implies P is negation Q or P. I wrote here, and then I'll take this is A. This is A. This is what? B. This is C. So A distribute A and C are B and C. Okay, and then from here to here again I am applying distribute law. This is A, this is B, this is C. So you'll get A and B, that is negation P and negation Q, or negation P and P. Similarly, R, apply distributive law here. Q and negation Q, or Q and P. So next I keep as it is. P and negation P is what? Contradiction, false, or Q and negation Q is false, or commutative law, P and Q. So we know that P, okay, consider this is P, P or F is what? P. Similarly, F or P is P. So we got the final answer. Okay, negation of P and the negation of Q are P and Q. So this is a proof. And this is, I think, third one. Next, fourth one. Fourth one is negation of P biconditional Q is equivalent to negation of, sorry, actually I want to prove it is equivalent to P biconditional negation Q. So proof. So negation of P biconditional Q is equivalent to, so we know that P biconditional Q is equivalent to what? P implies Q and Q implies P. So which is equivalent to negation of P implies Q is negation P or Q and Q implies P is negation Q or P. Now I'm going to apply De Morgan's law. I'm going to take negation inside. So you'll get negation of negation P or Q here, and negation of negation Q or P, which is equivalent to, so negation, take again De Morgan's law, P and negation Q, and negation of negation is you get Q or sorry Q and negation P. Okay, now here I'm going to apply distributive law. Consider this is A, this is B, this is C. The whole thing is C. Okay, this is A, this is B, this is C. So you'll get A and C. What is C? Q and negation P. Okay, P and A and C, and then here have and this, and I am writing here. Next B is what here? Negation Q. That is B. Again C. B and C. C is Q and negation P. So which is equivalent to, so here you have okay, I think I done the mistake. Yes, I done the mistake. Sorry. Here, if I apply the negation inside, here, okay, negation.
In that, sir, and should be converted to R, sir.
Here, this one, nah.
Yes, sir.
Okay, pa. Thank you. Pa. Thank you. That's why I'm checking. Thank you. So because if I apply De Morgan's law, negation of this quantity or okay, negation of this quantity. Okay, thank you. So because of this, I struck here R. Okay, wow. So and hence here also you'll get what? R. Okay, this is A, this is B, everything is C. So A, R, C. Okay, and then and this and is here. B, R, again here R. R, B, R. This is entirely C. This is A. This is B. This is C. Okay. Now, again apply distributive law. So this is equivalent to P R Q, P R Q and P R negation P, and apply distributive law, negation Q R Q and negation Q or negation P. Okay, so now the next step I'm going to write this is actually as it is, there is no change. This is true. Okay, this is also what? True. So I'll keep this one as it is. So which is equivalent to P R Q and T and T. Again and negation P commutativity law, negation P or negation Q. Okay, now we know that P, P and T is what? P. So here P R Q and T is what? P R Q. Similarly, same law, you will get P and Q and negation P or negation Q. Okay, now which is equivalent to, I'm going to write this is Q or P. Okay, wow. Q or P and negation P or negation Q. This is equivalent to Q or P. You can write what? Negation Q implies what? P. Because P implies Q is what? Negation P or Q. So if I take negation of negation Q, will get what? Q or P. And this one you can write what? P implies negation Q. So from this you can easily write P implies Q and Q implies P is what? P biconditional Q. So P biconditional Q is what here? Negation Q. So this is the final result we need. P biconditional negation Q. You can check it. This one. So next we'll move to the problem. First problem. The first problem is negation of P biconditional Q is equivalent to P or Q and negation of P and Q. Okay. So by using the previous result solution, because the previous result left hand side is what? Negation of P biconditional Q. By using previous result, so actually you need to write everything. Okay, from here to here you should write everything up to this step. Up to this step. Okay, so now I'm going to write directly P negation of P biconditional Q is equal to this one, this step. So negation of P biconditional Q is equivalent to negation of what? P. Sorry, I think first I write this. Okay, Q or P. Q or P and negation P or negation Q. So using the previous result. Now this is equivalent to actually what I need, P or Q. So by using commutative property P or Q, here apply what? De Morgan's law. So negation of what? P and Q. That's over. So P or Q and the negation of P and Q. So that's why you should know the proof. If you know the proof, then you can try to solve some of the problems quickly. Now I'll go to the second problem. So this problem already we discussed in the previous class, but I don't write. Just the PDF I explained quickly. So P implies Q and R implies Q. R implies Q is equivalent to is equivalent to P or R is equivalent to P or R implies Q. So okay, now I'll take the left hand side. P implies Q and R implies Q, which is equivalent to P implies Q is negation P or Q, and R implies Q is negation R and negation R or Q. So here you can see here this is and here you can see RQ. So we should apply distributive law here. So which is equivalent to, so this is equal to what? Negation P and negation R, and then RQ. You should take commonly RQ. That is a distributive law. So which is equivalent to take apply De Morgan's law, negation of P R R RQ. Now again the first law, P implies Q is what? Negation P R Q. So negation P R Q is what? Again P implies Q. So this is negation P R Q. So you can write P here. P is what? P R R implies Q. So that's all. The solution. I'll move to the next problem, third problem. So prove that P implies Q implies P is equivalent to negation P is implies P implies Q. Okay. So now solution. So I'm going to take the left hand side. P implies Q implies P, which is equivalent to, so keep P implies Q implies P is what? Negation Q or P. So again P implies Q, apply the same rule. So negation P or negation Q or P. So everywhere you have what? R. So you can apply associative law, commutative law, okay, and you can write this is equivalent to P or negation P or negation Q, which is equivalent to, this is T or negation Q. T or negation Q or T or P is T. This is the left hand side. Similarly, I am going to take the right hand side. I am going to prove that is also equivalent to t. So what is the right hand side? Negation p implies q is equivalent to negation p implies q is negation p or q. Again p implies q. This is equivalent to negation of negation p or negation p or q. So again here also we have or. So apply associative law and commutative law repeatedly. We'll get p or negation p within bracket and then rq. P r negation p and then rq. Again this is equivalent to t r q. So this is t or q is t. So the now the final step. So what is the left hand side? P implies q implies p is equivalent to t, but t is equivalent to this t is equivalent to what? Negation p implies p implies q. So from this we have this is equivalent to this. P implies q implies p is equivalent to negation p implies q. Okay, so that's all. We'll move to the next problem. Okay. So prove that p implies q implies r is equivalent to p and q implies r. Solution. So I'll take the left hand side. P implies q implies r, which is equivalent to, you can write this is p implies q implies r is negation q or r. So again p implies q is what? Negation p or negation q or r. So again everywhere you have r, you can apply associative law. You'll get negation p or negation q and then r by applying associative law. Negation p or negation q within bracket or r. Now which is equivalent to apply De Morgan's law, negation of p and q r. So now this is of the form negation p r q. So you can write p implies what? Q. What is p here? P and q implies r. So I think that is the thing I need to prove. P and q implies r. Next problem, negation of P, negation P and negation Q and R, close the bracket and close this bracket, and then R, Q and R, P and R, which is equivalent to R. Solution. So first I'll take the left hand side. So if I take the left hand side, negation P and negation Q and R, R, Q and R, P and R, which is equivalent to here you can apply associative law. Okay, if you apply associative law, what you will get here? Negation of P, negation P and negation Q, negation P and negation Q and what? R. So this is here I am applying associative law. From here to here, associative law R. Okay, here I am going to apply distributive law R. Okay, wow. Here, here R, here and R, here what? And R. So then what you will get here? Within bracket Q R P, a bracket like this, and then and R, close the bracket. Now this is equivalent to here I am going to apply De Morgan's law, negation of PRQ, negation of if I take negation common, so PRQ, and then what? R. So here you have again R, apply commutative law PRQ and R. Now, so again this here you have and here you have here you have R. Okay, here you have and R and R. So distributive law. So if I apply distributive law here, so what you will get? This is equivalent to negation of P R Q R. Okay, well, this is what? P R Q, close the bracket, and then and R. So from here to here, I'm using distributive law. So next, this is actually what? P R negation P. P R negation P is what? I'll write here. Okay, next slide. True. This is true. And R. True and R is R. So especially you should know the laws, okay, and then you should know which law you can use in which place. That is also most important. And one more problem we'll discuss. So P R Q, P R Q and So negation of negation P and negation Q or negation R, close the bracket, close this bracket also, close this bracket also. Okay, R negation P R and negation Q or last term negation P and negation R, which is equivalent to tautology T. Okay, so now so I'm going to split the problem slightly. So here first I will take this portion, okay, these two portions. So negation P and negation Q or negation P and negation R. So here this is equivalent to apply De Morgan's law. So what you will get? Negation of P or Q or the take negation common here P and P or Q here also P or R. Here also apply De Morgan's. This is equivalent to, so again I am applying De Morgan. So I take negation common. So P R Q and here and P R R. So next step here and here have and here what P R and here P R. So apply distributive law. So negation of P R, okay, P R is common. Remaining have what? Q and R. So I call this is equation number 1. Okay, now I'll take the entire portion. So what is the entire portion here? This portion P R Q and negation of negation P and negation Q or negation R, so which is equivalent to P R Q and I keep this negation as it is. Here you have negation P and so apply distributive law. There is no need to apply distributive law. You can keep negation P. You can also apply distributive law, but I don't apply distributive law. Negation P and here I am applying De Morgan's law. If I take negation common, what will get? Q and R. Q and R. Close this bracket and close this bracket. Okay, so this is equivalent to P R Q. If you apply again De Morgan's law, if you take again negation common, negation of negation gets cancelled. You'll get what? P and Q and R. P and Q and R. Close the bracket. So now
Sir, PR.
ஏதாவது மிஸ்டேக் இருக்காப்பா?
Yes, sir. P, R, Q, and R. Sir. De Morgan's
Okay.
law.
Okay, yes, thank you. Same mistake I'm doing again. So here P, R. Okay, thank you. So now for this portion, I am going to apply distributive law. So uh, PRQ and the applied distributive law PRQ and PRR. PRQ and PRR. So again, we know that P and P, okay, is what? P. So that's why we have P and Q, PRQ from these two and PRR. Okay, since P and P equal to P. Okay, I call this is equation number 2. Now, the given problem. What is the given problem? This problem. Okay, well, this is the whole thing. So I need to write again. Okay, I'll write. So PRR, PRQR, PRQ, PRQ, and negation of negation P and negation P and negation Q or negation R, close this bracket and close this bracket, and also here also I put a bracket, and then R, negation P and negation Q or negation P and negation R. Okay, now from 1 and 2 you can write like this. From 1 comma 2 we have, so instead of this we can replace by these two quantity P R Q and P R R. Or instead of these two I can replace negation of PR, negation of P R Q and R, R Q and R. Close this bracket, close this bracket. This is equivalent to, again I am going to apply distributive, and here PR, PR. So P PR common, okay. So Q and R, close the bracket, close the bracket, with R, this R, and the negation of P R Q and R. So now this is P, everything is P or negation P. So we know that P or negation P is what? True. So that is I want to show that. Okay, okay. So replacement process is nearly over. So now next section, I will introduce normal forms, and then we will solve the problem. I'll give the definitions of normal form today. The next class we will solve the problem. Okay. So the normal form here, this is Okay, just I will show. I think it is visible to you. The normal form. Just the definition is here. A product of variables and their negations is called an elementary product. Similarly, a sum of variables and their negations is called elementary sum. So a formula which is equivalent to a given formula phi and which consists of sum of elementary products. So that is you already studied. Okay, sum of products. Sum of products is called disjunctive normal form. Okay, DNF in short form. DNF. And similarly, a formula which is equivalent to a given formula phi, which consists of a product of elementary sum, is called conjunctive normal form. So CNF. For example, the formula P, negation P and Q, negation P and negation Q are examples for elementary products. The formula P, negation P, P or Q, P or negation Q, negation P or negation Q are examples for elementary sum. So here the procedure is here, but the step one is enough. Okay, so usually okay, here they gave a procedure to obtain a disjunctive normal form of the given formula. Suppose if you have a connectives, okay, that is implies. Here you can see this is the connective. So if you have this connective, first you should remove this. Okay, so how to remove this? Suppose phi implies psi, you should replace this by negation phi. P implies Q, negation P or Q. Similarly, you should remove this biconditional first. So P biconditional Q. So P biconditional Q in the formula P and Q are negation instead of phi biconditional psi, phi and psi are negation phi and negation psi, or negation phi or psi and negation psi or phi. So already I gave this results. Okay, so these two are very important. So instead of phi biconditional psi, you should remember this one and this one. Okay, so after applying removing these two symbols, okay, connectives, you need to apply De Morgan's law or distributive law, associative law, okay, De Morgan's law, and then you need to simplify further. So this is the main idea. So we will solve the problems in DNF and CNF in the next class. If you have any doubt, you can ask me. Otherwise, you can leave. Maybe probably tomorrow I'll take the same time. I will take the class. We'll discuss DNF and CNF. Thank you.